So for the longest time, data was deemed as a technical asset. But I think we'll all agree that over the years, we've seen a shift and kind of a recognition that data is really a reflection of our business processes. In our next segment, Amit Weitzner, the CEO of Timbr.ai, is going to take us through the challenges of turning business concepts into real-world data models and data architecture. And he's going to talk about how they can leverage, or they are leveraging EDMC's FIBO, the Financial Industry Business Ontology. So Amit, let me turn the microphone over to you. And can we unmute?
Yeah.
There we go.
Hey, John. Thanks, John. Excited to be here. Today, we're going to talk on the gap between how business grasp their domain and how these being translated to concrete data models. On the one hand, we have the business that tries to use data from the business perspective. And on the other hand, we have data models and on how we try to store information inside our own domain. So what is left behind? What is left when we start with the conceptual model, with the business concept, and now we need to figure out how we store information in our domain. So we start by moving from the conceptual model to the logical model. We start by talking about data structure, logical connections, and then we go to another level, which is the specific DB implementation, how we can store all of our data specifically in one database or in another. And moving from the conceptual model, we use all the business concept of what we have in our domain. And this really affects the way we retrieve information. So when I query the data, I don't want to work with the physical model. I want to work with the conceptual that represents the business. So what is FIBO? FIBO is the business language of the financial industry. It contains financial instruments, legal entities, market data, and financial processes. And when we talk about common semantics, we're actually talking about how the business wants to view the data. So FIBO gives us that possibility, the business view of how the data should be represented and modeled. So from the business standpoint, you don't want to look at the ERD or the tables, you want to look at the business entities. So to summarize FIBO, we want business meaning in business language for business people. And this gives us an example that will show you what's the difference. So when we talk about equity, we have the dictionary of what is an equity and how we can explain that from one human to another. So an equity is a financial instrument setting out a number of terms which define the rights and benefits to the holder in relation to their holding a proportion of the equity within the issuing company. When we try to formalize that to a machine readable format, we start by the conceptual model and we can model it as follows. We can look at an equity in a relationship to an instrument terms, has rights defined in an equity security, which is kind of a financial instrument. So we took that human definition of an equity and we tried to model it from a business perspective of what are the entities and relationships we have for that. But in reality, what happens today in most enterprise, when we try to take this conceptual model and we move down the layers to the physical one, this is how an equity really looks like in the database. And when someone wants to figure it out what an equity looks like from a data perspective, he needs to figure out where, in which tables, in which database this is stored, what kind of relationships, all that information goes away. And now we need to figure it out from the technical point of what is an equity. So the information that was left behind, we do try to look from the question point of view. If I go and ask what types of equities are owned by customers, So now we need to take a business question, translate it to a specific physical model or multiple physical models. And this, on the right, you can see an example of a query that someone needs to take that business question and translate that to the specific physical model. Imagine that if you could ask this question, not on table and columns, but on entities, relationships that represents your business. This is what FIBO can offer, and ontologies in general. If you would ask this question not at the physical layer, those questions become simple and intuitive. So we know that there is a gap. There is a gap between how we store information in the physical tables and how the business views the domain and wants to conceptualize all the business entities, their properties and relationships. How we can bridge this gap? There are several ways to bridge this gap. First, we can start over. We can throw away all of our concrete models and try to build or model from a business standpoint. So we need to throw away all of our infrastructure. We need to hire new personnel. And this is very cost and takes a lot of time. Very costly and takes a lot of time. What happens in most enterprises today, because it's very expensive to start from the model from new, they try to manage. They try to manage the complexity that was created in the specific concrete data models, and this turns out to be from complex queries to embedding knowledge in an application in code. You need to code your business logic in applications to handle the complexity, or in sophisticated BI tools and analytical tools. The third alternative that we offer and we propose is not try to replace. It's not one or the other. Let's connect all of your data, all of the existing infrastructure, and see how we can leverage both of the technologies, both of the approaches. You get the physical layer that's in charge of performance, of managing security to the data, of indexing and scalability. And you have the conceptual model that tries to view the data from the business standpoint. This, combining those two approaches, lowers the cost of adopting the financial ontology and ontology in general, accelerates the implementation because you don't need to change the existing infrastructure you work today, and knowledge can become reusable and shareable across the whole enterprise. So Timbr transforms data engines into knowledge graph. We believe that the correct approach to solve that problem is not to replace one with the other, is to connect those two and to build a solution that is easy to implement and does not change the way people work and consume data today. So if we try to look at it from a data consumer perspective, so here on the left, we can see a data warehouse schema view, which is very tech-oriented because we have a list of schemas. For each list of schema, we have a list of columns. Now I need to figure out how equity is being stored in my database. On the other hand, we have the ontology view, which is business-oriented, that shows me the conceptual model, not how it is stored in the table, but how I want to see the business, what kind of relationships I have, what kind of properties, and so on. But the major difference here is that people do not think in terms of table and columns. When someone works with an analytical question or has a report he wants to build, he does not think about how do I connect those tables. He thinks of the business question, the business need, and it's very hard today to translate those to the concrete physical implementation. So let me show you the benefits. Here is an example from a fraud detection use case, where working with the physical model, you need to aggregate all of those tables, understand how to translate the logic behind the fraud detection to the specific data models. So you can look, it's complex to write, it's complex to maintain, and people today are struggling maintaining those kind of queries. But if you adopt a conceptual model and you expose to the data consumers, not the physical representation, the conceptual representation. In the financial domain, you have FIBO for that. All of the queries become simple and intuitive because you're talking about higher level of abstraction for your data. And you don't need to understand how to aggregate, where the data is stored, how to connect all of the data. All is done for you in the semantic layer. The other benefit you get by working with a conceptual model is now you can explore data through the business lens. Imagine that today exploring data in a tabular format, which is the most common way of storing information today in a relational database. It's very hard to explore relationships, explore in terms of the business view of the data. We believe that once you work with the ontology and in FIBO in general, it's easy to look at the data as one virtual graph from the business perspective. You don't need to understand where the data is or how it is stored in order to see the relationships that exist today in your data. And this capability is missing from a lot of applications today because they store the physical model and not the conceptual one. And the focus here really is about a language, a modeling language that allows you to add semantic annotations, but also focus on type of relationships. So I want to talk about the FIBO potential of how we see it. So you have this business conceptual model you can leverage, you can implement in your enterprise. And on the other hand, you have your existing infrastructure. You have all your data stored in different data engines. You have different concrete data models. How you can connect those two? And what are the benefits of connecting those two? So if we try to combine them and not try to replace one another, the benefits for IT is you get data harmonization, you get a 360-degree view of the data. You can formalize your business logic and code all of your business definitions alongside with the data. This allows you to get two distinctive capabilities. First, you can share data between business units, and this also allows you to derive integrated decisions. But this is from the IT perspective. If we talk about compliance, adopting a business conceptual model allows you to be compliant for regulatory data requirements. You can enhance and get better governance and architecture of all of your data. You can build risk data aggregation and risk reporting faster in a business language, and it also enables you supervisory review. So connecting the concrete data models with the business conceptual model opens the whole world for a new set of capabilities that should not be competing one another. They should be complementary. They should be together. How we can bring this to enterprises as fast as possible without trying to teach or change the way they work with data today. Thank you very much for being here today. It was a pleasure presenting to you.
Amit, that was excellent. What I really liked about that, and something we've been talking about for the longest time, is viewing data from a business perspective and not just a technology or structural perspective. And I think you've really highlighted, using intuitive thinking into data instead of it just being, something that's just highly technical. A great presentation, really something to think about. Mike, let me turn it over to you. I saw some questions come in. We have a few minutes, and we have Amit here with us. If you'd go through some of those questions.
Absolutely, John. So one of our audience members by the name of Antonio just put in a question, and it goes as follows. So Amit, the question is, with so many new data sources every day, how does this ontology help match the new technical data with the conceptual layer?
Great. So by combining the two approaches and not trying to replace that, you can map any data source to the conceptual model. The way we offer and we think is the solution is that if you already create a new table, a new database, you should use the same skills you already know to map to the conceptual layer. So if you know SQL, you know how to create a new data source, a new table, you can use SQL to create the conceptual and map to the conceptual level. So in terms of doing this, it's just implementing inside the enterprise. Every time you create a new table or you generate a set of new data sources, part of the creation process should be, now how can I match that to the conceptual level? And the benefits are huge because you have the business definition and you can see whether the new data you have can be matched, or do you need to extend the conceptual model with new business entities or new relationships.
Amit, thank you. Another question came in from Marcel, and it goes as follows. What could be the impact of applying virtualization on top of badly designed databases?
This is a great question. So when you map all your concrete data models, you are limited by the performance of the existing databases. So our proposal, and this is also, I think, in terms of cost benefit for the enterprise, instead of replacing your concrete model, which is very expensive, you should materialize only the data or the joins you're doing with the data that are badly designed and could produce bad performance. So you don't need to change all of the data structure from day one. You can change only parts of it and materialize parts of the data to the conceptual model specifically for performance issues. So it's an adaptive process that you can also learn from your existing workloads. So if you have a subgraph from the ontology that you work and you have more complex questions on, you can say, I want to materialize only that part and not all of my data, which is very expensive and hard to do.
Amit, thank you. So for a final question, this is from Nicole from our audience. It's a great question because often the challenge with new capabilities is simplifying. How do you explain that to business users? So the question goes as follows from Nicole. How do you explain the value of an ontology to the decision makers in the business?
So this is a great question, and we can look from the last couple of years, all the implementation of knowledge graphs and the benefits they've given inside the enterprise. But we believe the main benefit is when you can facilitate all of the technology complexity behind big data, behind working with complex data models, but also if you want to have new type of queries. So the business changes all the time. If you model for a specific type of questions, usually this model is very hard to change for when you have a new type of question. But working with a conceptual model with knowledge graph, when you try to look at it from an abstract, high-level business perspective, you can answer a lot of different type of questions without modeling specifically or ad hoc for a specific question. So imagine that if you're a consumer good company, you can classify in the model all of your products, all the type of consumers, all the type of promotions you have. And now each business question is just a matter of addressing the right business entity from that conceptual model. You don't need to understand how this business entity, a specific product, a specific customer type, or a specific promotion is stored in the hundreds of tables you have today in data warehouse and data lakes.
Amit, almost in your response, my takeaway is that the conceptual model is organized in the way we relate and humans and business people think about their business. So it's actually an improved design to let you answer the questions that you have going into the future. So Amit, thank you. In a moment, I'll turn it back to John. Just one comment. We did have a couple of questions. Your slides were very much enjoyed, and there was a question, will we be sharing these? And the answer to all of our audience members is yes. After this event, we will be providing both recording links and the copies of the presentations. So yes, we will be getting those out. So John, over to you.